Done.
Thank you. Thanks, Rajesh, for bringing me here. Okay, so I'm going to talk about multi-platform. That is also a buzzword. So everybody here is Android developer, I assume, right? Everybody is using Android developer. The meetup name is DroidTribe. So any Apple fanboys in the house? Only one? Okay. So if you remember the old times, like I am very old in this field. Like it's when I started building Android when we used to use Eclipse, if you remember. Remember those times? So that time there was one more multi-platform or hybrid thing, if you remember, that was called Iconic. Okay, so it started with how we packaged the application in a web view. Iconic, then other libraries came, for example, React Native and Flutter. And now we have Kotlin Multiplatform. So that's what I'm going to talk about. And I'll keep it about Android and iOS. You can build desktop and apps also using Kotlin Multiplatform, but my focus is on iOS and our two major mobile platforms, right? So we have two universes, and in every company we have two teams, right? One is Android team, like I work always in Android team, and one is iOS team, and both are building the same thing. Like experience the same, correct? So what if we can merge these two teams? Now it may lose some of the jobs, but it's okay. But building an application for both the platforms has their own challenges, right? And one Apple fanboy is here. So what do you think? Which one is more difficult, Android or iOS? Did you try iOS UI?
Yes. But I still believe like Android is difficult comparatively, but it's also easier to learn. So we can overcome the difficulties compared to iOS. In iOS we can't even overcome Xcode, so there's no.
Yeah, so I recently started working with this KMP, and you have to use Xcode with that, and it's really crazy. Like sometimes it crashes, and it's the worst IDE I have ever seen. So, but yeah, building for Android is difficult, right? Like in production, we get like why this application is crashing in that Poco device. And iOS folks, what they get, like app is rejected from the App Store. So this is how the contrast between the difficulties of both platforms, right? But the problem with making two different applications is you need to learn, if you are doing it alone, but it is not the case for most of the companies, but if you are trying to build something and you want to target all the mobile platforms, then you have to learn two different IDEs, and we discussed like Xcode is a nightmare, and two languages like Swift and two different frameworks. So the total effort is multiplied by 2. So what if we can bridge these two universes and use Kotlin Multiplatform to share all the business logics, right? So we write a lot of API calls, model classes. So when Kotlin Multiplatform came, what you can do is you can create one module and you can write all the codes except the UI in a common module. And you can share it with your iOS. And it is native, right? It is not some hybrid technique or workaround. The Kotlin code compiles to native iOS libraries, and that you can use in your iOS application. That's how you share most of the code for your project, correct? So that was about Kotlin Multiplatform. It simplifies the development. You can share the majority of the code. And the idea was you need to write once. And whenever you want to write some platform-specific thing, for example, file picker or gallery, picking image from gallery, you can also write the platform-specific code. And when you're using only Kotlin Multiplatform, anyways, you have to write the UI part for both the platforms separately. Okay. And it supports all the platforms, like it has for backend, web, desktop, and mobile, right? So this was the idea, like we use all the backend skills. So it's nice, right? Even I as an Android developer and go with the backend guys and check what's the problem and write the code. And it increases your work effort, and if you're doing the same in your company, you might start getting backend tickets as well. So the reason to choose Kotlin is we love Kotlin, right? After we migrated to Kotlin, there's no going back. Anybody still using Java or XML in their applications? Everybody is migrated to Compose. Anybody who still prefer like Java and XML? No one, right? If someone was there, that would be surprising. So, and we get native performance, and the best part of multi-platform is you can gradually adopt it. For example, you have an Android application, you have an iOS. You can start slowly adding the iOS screens in your Android project, and eventually you can ditch the iOS project. So this is how you can gradually, you can slowly, feature by feature. It's not like you have to migrate. Like for example, you are migrating from Android to React, then you need to migrate the whole application. Like it's total refactor. But here you can slowly do it, right, gradually. So that's the best part. So how it works, all your Kotlin code is compiled into XC workframe that your iOS project can consume. So when you create a Kotlin multi-platform project, you get these modules, right? The first one is the Android app, where your Android app is there. Then you have iOS app. This is an export project, right? You can also open it in Xcode. And then this is the main part. This is the shared module. Here also you have Android main, where you will put platform-specific Android code. Then you have common main. And inside this module, you will put all the codes, right? Everything that you can share between platforms. And for example, you're writing shared preferences to save values. Then what you can do is you can create expect class in your common module, and then you can write platform-specific implementation in Android and iOS, and also desktop or JVM if you're using them. Okay, so to write platform-specific code, what you can do is you can use this new keyword if you know, that is expect. So in your common module, you will write an expect class or function, and you put all your functions, and then for each platform, compiler will know, right? You will get compile time error if you don't write actual implementation. So in your Android, you write this, you will use this new keyword that is actual, and now here you can access the Android specific libraries. So I can use shared preferences, I can write save and get function, and whatever you want you can write it here. And same for iOS. If we use NS user defaults to save key value pairs in Xcode. So you can write the specific implementation, right? But the main problem with Kotlin multi-platform was we have the common code, and we have the native UI, and we have the iOS native UI, right? So it is like building the same all the screens again repeatedly. Okay, so again effort multiplied by 2. Now to fix this, we have Compose Multiplatform. Started using?
Yes.
Okay. So the same Compose thing, it is nothing new. Like the same Compose that you are using, you can just copy paste to the common module and it should work, right? Unless you're not using any Android specific library. So Compose is multi-platform. It can render the UIs in iOS, desktop, web as well. So these are the platforms supported now. iOS recently became stable. So many companies also started using, multi-platform to reduce the number of employees. So Android, desktop and web. So you can build UI for all the platforms, right? So it gives you the native feel. Now again, if you are using Compose Multiplatform for iOS, it is not actually native. It just gives you the native feel. What happens? It uses, I think, a rendering engine. And when you compile the code, it creates a library that is exposed using a UI view controller. And you set that UI view controller to your main application in the iOS. And that renders the Compose. So it is a little bit heavy. It gives you the native feel, but it is not actually native like iOS. But again, you can also do the gradual adoption. You don't need to migrate all the screens to Compose. You can do it bit by bit. Like still in some big projects, if you are working, you might see the XML code, right? So you can slowly migrate, and same you can slowly do for your iOS screens. And we all have the Android skills, right? So that's the best part about Compose. We can use our skills to build the iOS screens also, and it works, interoperably. So you can call Swift code from Kotlin and Kotlin from Swift. So both are allowed. So what happens is you write the Compose code, you compile it, and then it generates an iOS framework that is exposed to your Xcode project, and that is set in the UI view controller. So that's how it works, right? I will show you a project now. So the drawbacks are, it uses a Skia rendering engine. The UI is drawn pixel by pixel. So it is a little bit heavy. both in times of compilation and while running the application. And you don't have support for the native iOS components, that UI switch and other stuff. And it is, I told you, heavier than Swift UI because it draws everything. You know, every time a new component you have, it draws in the iOS screen. So, and to create a multi-platform project, you need to get this plugin, that is Kotlin Multiplatform. Okay, so you go to your Android Studio settings, plugins, and in Marketplace you will get this plugin, and you just need to install it, and you will get this template while creating a project, that is Kotlin Multiplatform. And when you click it, you go to next, and it asks you for all the platforms that you want to build for, right? And you can select the platform, and for now, the project I'm going to show you, I created for Android and iOS. So I'll show you now. This is a sample project that I have created using Kotlin Multiplatform. I had made a note like what are the things I need to show to you guys. Just let me open it. Huh? Okay, so the first thing here you can see is Composer. Now when you use your shared UI, you get this module, that is Composer. And this is your Android application actually, right? Now inside the Compose app, you have common main and iOS main. Now all the platforms will be here. I have created this project for Android and iOS, so I have common main, iOS main, and the Compose application.
Is it visible to everyone?
Yes, it's visible. Shall I increase the font size? Huh?
Increase the font size.
We want Belal to change to widescreen.
I'll increase the font size. Try this.
You can just pinch the this thing. Pinch it.
Pinch. It'll work. Better. Yeah, this I can change, but this part I don't think I can change.
Visible now?
Okay, so you can see this is the application, okay? Now for dependency injection, I'm using Coin here because that's easier in a multi-platform project. So you just write Coin application, you put all your modules, and you will get every model. The problem is, it is, it gets your dependencies in the runtime. I forget the term for that, if anybody remembers. What do you call it?
Service locator?
Not service locator. So we have two ways of dependency injection. One is the compile time dependency injection, one is runtime. I also forget what
Service
is
locator.
Service locator is not like, no, that's not the term I'm looking for. Yeah, you can call it, you create a service that gives you the objects, but we call it something else.
Reflection. Reflection.
Yeah, correct. Reflection. I was looking for. So Coin uses reflection, right? It will not give you errors on compile time. But that's okay, it's very easier than Dagger and Hit. So you just create a Coin application, you put all your modules, and this is the application. Now this app will be exposed for your iOS project, right? And you will set it. You see, this is the iOS main. And here, if you go to main view controller, we are using a Compose UI view controller, and we are setting this app, right? So now this main view controller will be exposed as a library to your Xcode project. So if you see, this folder is the Xcode project, right? And here, if you go to, you see, we are getting the Compose app here, and this is our main view controller. And this is being set in your iOS application, if you see it here. You see? So that's how it renders your UI. And I'll also show you the common main. So for this project, almost everything I have in this common module, right? I have created a sample that you can check out from the repository. And I'm using Firebase, right? for a login sample, and there are a bunch of other things. So I have the application, I have this auth module, Firebase, links, plus utils, everything inside common module. So I am sharing almost 95% of the code in the common, and I have written specific implementations for Firebase, right? If you go to Firebase, then I have auth, I have DB. Now you see this Firebase auth client. This is an expect class, right? You see? So I have three functions, sign in, sign out, and get current user. And if you click here, you see this A. So you get the actual implementations from here in the ID. So ID is well supporting this actual and expect thing. So you can see I have the Compose app implementation and the iOS main implementation. So now this code is a little bit messy, but yeah. So this is the iOS thing that we are using Cocoa Quad for dependency, and the same I have written implementation for Android. Now when you run the application based on platform, it will pick the implementation that is needed, right? So this is how you work with a Compose Multiplatform project. Now I will show you the output. Now I cannot run it here. I will tell you why. It's funny. So that's why I have recorded this video to show you the demo. I hope this is visible. Okay, so when you make this project, you see the Compose app and you also see the iOS app. You can run the iOS app from here only, but you need a Mac, right? You cannot do it in Windows laptop. So now you run it, it will use the emulator that is installed using Xcode, and it takes a little bit of time. So this is the application, you see. This is the iOS one, and I'll run the Android one also. So everything, all your navigation code using Jetpack Compose, everything is supported in both platforms. So some libraries you will see in the package, you will see Android, but it is not natively Android, and you can use it in iOS also. So this is the Android one. So you see both applications are similar because they are sharing the same code base. And I can log in using Firebase login. And I have also a native implementation. For example, this screen uses WebView. So for WebView, you have to write the native implementations, right? So, but still both look same. So this is how you can use this. But I have one question for you guys. Can you guess why I recorded the video and did not run the application here? Any guesses?
It might take a lot of time.
Yeah, it will take a lot of time.
Now to run from iPhone here to a developer.
Yeah, correct. It will take a lot of time. Actually, it will take a lot of time because it is MacBook Air, and I built the project in my computer, that is Mac Mini. When I cloned the project, it was just not compiling. Why? It's not like there was some error. It is too heavy. Okay. So that's the next thing. Challenges. Not everything was amazing, right? It was the biggest problem, the waiting time. So we already saw the memes of Gradle build and things. Trust me, if you build a multi-platform for iOS, you will see the real pain. Because normal Gradle build is nothing. I can compile and run the Android project in my MacBook Air. It's fine. It has 16 gigs of RAM, M3, works fine for Android. But if I execute the iOS build, it might take, whole day or something, but just booming and booming. So that's why. Because what happens is, first the Kotlin code is compiled to your low-level virtual machine. And then it again compiles to binary ahead of time. Then it packages the framework, right? It exposes the XC framework that you use in your export project. And it has the incremental compilation, but even in my experience, even the small changes were triggering big compilations. So the compile time was huge. So I was not able to run it in my MacBook Air. So if you're using an Air, it's very, very difficult. So there are some tips to improve the build times. The first and the, what do you call it, Brahma is get a powerful machine. So if you have a powerful machine, it works fine. Okay, so it's not like in Air it doesn't work. Even if I have 16 gigs of RAM, it's not 8 GB variant. So Air, it doesn't work. So if you are using Air, you will have very hard times compiling a multi-platform project. So don't do it, I would say. But yeah, Mac Mini, I had Mac Mini M2 Pro, works very smoothly, very fine, it compiles. But it's still a sample project, right? I have no experience with industry level project that has hundreds of modules. So you need a good lab. Then you can turn on the build cache, and when you build the iOS, you have to build different binaries for simulator. I don't know why they do this, and different binaries for real device. So when you are developing, you don't need to build for real device, right? You can just build for the simulator for testing, and you can enable the parallel builds in your Gradle. And one more challenge while working. Anybody worked on Xcode? So like I was confused, like to add a dependency, first you need to install Cocoa Pods, create a pod file, then pod install, and then close your Xcode project and open XE workspace. Why the hell is that?
Sometimes that also not work. You have to delete the pod file manually, then reinstall.
Yeah, I'm coming to that. So I had this problem. Why? You have to close your project, open XE works, and if you're using Xcode project, it doesn't work. So it's an error, like error only. I don't know why. In Android, we just put the implementation and magic, it's nice, right? Cocoa Pod kiosk. And when you're working with Kotlin Multiplatform, you will have hard time while getting these dependencies. So I also tried Swift Package Manager, but I felt that is more difficult. Something it was not working in case of multi-platform. So I think iOS is still maturing quite a lot. So while building the iOS part, I was facing a hard time. A lot of compilation errors like Firebase not found, Firebase core not found, Firebase auth not found, all libraries just not found. So I had to do a clean build many times. And trust me, if I do a clean build in my Mac Air, again so I created this script that you can create with Gradle. So you have to delete pods, podfile.log, and XE workspace, other things, and then do this build. And again, first you need to generate the dummy framework and do all the things. So it was a lot of commands in a very specific sequence. That's why I created these two scripts that you can check in the repository, right? So it was actually very helpful if you're using Cocoa Pods. Do you use Swift Package Manager?
Little bit, not that much.
Yeah,
But
I don't think it's not much.
use Cocoa Pods.
Yeah.
That much I have explored. Like,
People use this Cocoa Pod, but it is very hectic and difficult. I don't know why.
but I'm from little bit of Flutter background. So
Okay.
there before was Cocoa Pod. Now lately they are moving to Swift package.
I think Cocoa Pods is maintenance, so they have to migrate to FSP.
Swift Package
I
Manager.
mean, the support may be experimental, but everyone is gradually migrating.
Yeah. Later they might.
Recently Firebase also stopped supporting
But
Cocoa Pod.
even with Swift Package Manager, the confusion was, you can create a file, but the default way that they say is go to application dependencies and with the GUI get the.
Yeah.
That was also, and the worst part about Xcode is, for example, I click add dependency, it silently fails without showing any error. So then I decided I'll use Cocoa Pods only because it was just silently giving error and not coming into my project. So yeah, that's all about Kotlin Multiplatform. If you wanna ask anything, I'm happy to answer. Sure.
First of all, about the rant about Xcode, yeah, I feel you. Second thing is, I have developed sample, pet projects in KMP and CMP. The one area I struggle the most is understanding the framework files that has bindings. For example, you have, like we have shared preferences. The equivalent of shared preferences is user defaults. But we don't write it as user defaults. We write it as NS defaults. NS default.
Yeah.
That's how we write, right? Because that is how the bindings get generated, right? As an Android developer, how do we, do we have to go through another framework like iOS, understand all the framework classes, and then because they have something like NS file, they have something called NS string. What is all this?
Yeah. So yeah, you need to get a little bit of iOS information, and I seen company building Kotlin Multiplatform. So I was ranting about losing jobs, right? iOS devs were there because not possible because them. Okay, so you need to learn little bit of iOS, Xcode, it silently fails, and very painful, the was IDIC. But yeah, you have to learn all these complicated Swift classes. I also don't have much idea about these because I just started. Yeah, but learning is required.
Yeah, because every time I need to, let's say, read an image from a disk, right? That's like a couple of lines of code in iOS. Bro, what is this?
Even a simple null check,
Exactly.
I think it's not straightforward, right?
It's a card.
You get something else. I don't remember exactly, but you get some values, you get some other values. It's not as straightforward as Kotlin. Though they say like the Kotlin was inspired from Swift, but I think Kotlin is much better. Agree with me? How many guys?
Actually, the developers who got the pain, who's
Yeah.
and simplified in Kotlin.
Yeah. But yeah, for all the native, for example, in this project, I created WebView. Okay. Again, Android WebView is very straightforward. iOS WebView is, you need to write a lot of bunch of things. So hopefully with ChatGPT and GenAI, I was able to do it. But yeah, the classes are difficult, not very intuitive. So there is a learning curve.
Because I was, usually poking an iOS guy or going through reading old Stack Overflow, from years and trying to understand. Okay, this class is for this. Okay, this is how we read an image.
Yeah.
This is how you read a PDF file.
So I think I also realized learning the basics of Swift because it's very different than the normal languages, right? That is very important because how the language works. It's important to know if you're working with it.
Thank you.
Yeah, my question is around the expect keyword that Kotlin Multiplatform introduces versus using interfaces for your abstractions. So initially when I started learning KMP, most of the things that I needed separate implementation, I used to do create an interface for that, create separate implementation in the source sets, and through dependency injection, I used to inject those specific implementations at the runtime for that specific build. As an Android developer, I was already doing this, and I was very familiar with this, so it was very easy, or you can say very natural for me. So I did not get what's the exact need for having this extra compiler, extra keyword to at compilation level. So any thoughts?
It's easy, right? You have to create an interface, implement that interface in both the modules, and then write the implementation. You can miss it, right? Compiler won't say this interface, this implementation is missing. But in case of expect, you get the tool in the ID, right? You can directly create all the implementation from, you click on that A icon, and it will give you the option to create all the classes and functions. And you will get a check on the runtime. So when you compile, you will get error if the implementations are not.
So it's basically
it's the same thing.
Yeah, it's the same thing
is happening.
Automate a few of the layers.
Yeah, they automated the outside layers. So it's better, right? It's easy and quick.
Got it.
I have just one question. So we basically migrated our network module to KMP. It was working fine in Android, but from the iOS folks, I heard that the errors were very cryptic. So they were not able to debug the exact cause, what was happening. So we basically in the production, we just saw what the Android error was and correspondingly we solved it in the module. But the iOS folks were having difficulty in identifying that error. Have you faced such an issue or have with that?
Yeah, I was working 1 year back. I was working in Pepe, Japan. So we were using the same thing. We were just sharing the network part as a library. So a different project for all the networking model class API things. But we didn't face this issue. Like we have the stack trace properly maintained, so iOS folks were also getting the networking. I was not maintaining this repository, but yeah, we created the library file, implemented the same library in both the projects, iOS and Android. And as a developer, we don't have need to write the networking retrofit calls. We just call the function what that repository folks were. It was nice, like seamless, no problem.
Got maybe some issue with obfuscation or something.
Hi Bilal.
Hello.
My question is that if I have some project running, so how to notice that KMP thing?
Sorry. How to start?
Hold it closer.
Yeah, I'm audible now?
Yeah.
Okay. I have one project running, right, both Android and iOS. It is big project, so we have spent 1 year developing that. Now if I want to introduce KMP, the business logic, then how can we do it?
So the first thing is you can start from your network layer. You can create a shared module that both your
Right, so to share the code, we have to export some library or execute for that, right?
So the first thing you can try is create a separate repository that will have all the networking part. Implement that library in both your projects, and this is how you can, this is very consistent. Like many times we have problems like, iOS folks are writing some different model class and Android writing different. So to make it consistent, you can do it. But if you want to go with, both UI sharing and Compose sharing, you can keep the iOS application, you can keep the Android application, and you can reconfigure your Android part to use the KMP and CMP. And slowly you can start migrating the iOS part little by little, and when the app is ready, you can launch it to the market. It will take a lot of time because if the project is already very big, I don't think it's a good idea to just migrate to multi-platform.
Yeah, let's say we are introducing any new module, right? Now we want to do this, right?
So there are only two ways, right? In your existing Xcode project, you can integrate your existing Xcode project to your Android one, but that will be very difficult. So you can only share the networking part, I think, for now. If you want to share the UI, you need to plan the whole development lifecycle.
Okay. So every time when we build something, right, we have to export the XC framework and import in the iOS project.
It happens automatically because in the project, that iOS app folder, that is actually the Xcode project. You can open it in Xcode and you can do the thing. So this configuration you need to do. Initially, it is very difficult to use an existing Xcode project and put it in your KMP project, but it is doable. You can plan this way or other sharing the business logic part.
Okay. Thank you.
I think there are case studies as well on the Kotlin developer page that can help you.
If you go to Kotlin Multiplatform, there are many case studies. McDonald's is using KMP and CMP. If you guys use McDonald's, I use it.
Hello, Bilal.
Yeah.
So my question is, like, in KMM project, are we forced to use single activity architecture, or we can create?
No, you can create multiple activities.
Okay, and while going through code,
when you are sharing UIs with both, iOS and you can create multiple activities. You can still use fragments, but little bit difficult because you have to manage a lot of entry points from your common module, right? Right now, I have only one app that uses coin module, and inside that I have all the nav host and all the other screens, right? But if you make different activities and multiple entry points for your application, then you need to manage all these things.
So basically, we have to create expect an actual for calling the activity, and then we have to share the common code.
No. Then you need to create, different, what do you call it in Xcode? UI controller, right? And we have activities here. So for every activity, you will get, exposed compose entry point that you can use. So, multiple activities, multiple entry points from Xcode, and you can use multiple composable that you embed inside your activity and inside the Xcode UI controllers.
And while going through code, I saw that even if we are writing actual implementation in iOS code, but that code is in Kotlin itself.
Yeah.
Okay, so like I was struggling to find documentation for it.
Yeah, documentations are evolving, so less resources, but yeah, slowly many things will come. But yeah, when you write the native implementation in the shared modules, iOS module, it has the Kotlin code only. In some cases, for example, in this project only, Firebase Firestore SDK is not available for, I think it is only available in the Swift code, okay? So for that, I had to write a wrapper in Swift that I can call from Kotlin. So yeah, you will face problem with few libraries. In that case, you have to write wrappers.
Thank you.
Yeah, I see, I hear so many challenges here with Compose Multiplatform. Maybe there might be in Compose, Kotlin Multiplatform and Compose Multiplatform. I mean, first thing I want to just clarify that Kotlin Multiplatform helps in shared business logic. Is that true? Okay. And Compose Multiplatform helps in shared UI.
Correct.
Okay. So, I mean, what is your experience, from your experience, combination of these two with comparison with Flutter?
I'm not the right person to answer this because I have never used Flutter.
Okay.
But uses the same, the methodology is same. Like same way, Flutter also renders the UI pixel by pixel.
Yeah.
And Compose also do the same. I think Google is now little bit lazy in case of Flutter. I don't see much activity being happening.
As far as I have attended the events of Google,
yeah,
it's not so, and also I have a different viewpoint.
Yeah, maybe, but like 1-2 years back, Flutter was in all boom. Everybody was doing Flutter. I don't see. Maybe I'm wrong.
So yeah, I share my viewpoint.
Yeah,
maybe at the end of the event.
Yeah.
Yeah.
So I don't see like putting effort, like either they continue Flutter or Compose, but both does the same thing internally, renders the UI.
Yeah. Hello. Hi, Belal. So I have just two questions. One is like when you shared the project structure, so there were two sections where the Android main, iOS main, and inside the shared module we had Android main and iOS main. So what are the differences, the classes that we need to keep in those modules?
So you get two modules when you share the UI also, right? One is Compose app. That is your actual Android application that has the Android manifest file and it will be installed in your device when you run it. And you have iOS app, right, in the top layer. This is the Xcode project, okay? Then inside you have one more module that is common. And inside common you have one more common, Android and iOS. These are for writing platform specific definitions, right? And common will have the majority of the application that you can share between all the platforms, whether it is business logic or UI. So inside these you can create your own modules. The same, you can follow MVVM and clean architecture. You can create data domain layers in the common part, okay? And whenever you need, for example, if you need to write a web view, you need a native implementation for iOS and Android. In that cases, you will use the same modules inside the
common.
Inside common you have iOS, Android both and common.
Right.
So inside this common iOS and Android, you will write the native implementation.
And what about the top layers?
Top layers has the application. For example, Android has the manifest file. Okay. iOS app has the Xcode project.
Okay.
So this iOS Xcode project gets the XC framework when you compile, and that is exposed to your Xcode. You can also open it in Xcode and do some tweaking if needed.
Okay, understood. And the second one is like, as you mentioned, that the iOS is stable on Compose. So is like if a person is using CMM rather than KMM. So like apart from having some difficulties in the UI section that iOS follows, but we can't use it using Compose. Apart from that, what are the other challenges if a user is, like if a developer is building a project on CMM rather than KMM?
Like KMP is for sharing the business logic part, right?
Yeah, right.
And Compose is for sharing the UI.
Yeah.
So you can use KMP, but in that case, you need to write individual UIs for iOS and Android or other platforms. If you use Compose, you can also share the UI part, right?
Yeah. So if a user like developer is using CMM, like for the UI sharing the UI logic and the business logic also. So like what are the other challenges apart from not having the proper native field?
Yeah.
what are the other challenges of using CMM rather than using KMP?
I don't see any other challenges. One is the build and Xcode issues, and like you need to write your iOS apps for material design guidelines, right? Because it uses material that is not native to iOS. So that's the only challenge. But you can tweak your composables to match, iOS, but better to use material, I think, personally.
Thank you.
Yeah, I think that will be all for the questions. Belal will be available, just connect with you, and we'll have more questions in the panel discussion as well. So before we move ahead for lunch, thank you, Belal. And before we move ahead for lunch, we have posted a link in the channel. So as Rajesh spoke earlier in the morning, we will have a lightning talk or a flash talk right after lunch. You folks can register your interest. You can put in your name and what you'd like to talk about. I mean, this could be a good opportunity to take the stage if you haven't done previously. We'll wait for 10 minutes for that and we'll drop for lunch. Thank you.
Thank you.